Alright, so here's your first worksheet. It's on section 1.5, rounding and estimating. And I want to explain what this packet is. So you'll see at the bottom that it's worth 2 10-point in-class, out-of-class homework / quizzes. So you get 10 points just for watching the video and taking notes, and you get another 10 points for doing the problems that say, here are some for you to try. And I'll point those out, and I'll recommend that you stop the video, try the here are some for you to try, and those are the ones that I specifically grade. So let's talk about what rounding means. So to round a number, for example, to the nearest 10 means to decide which 10 it is nearest to. Okay? So notice I have a number line here that is counted up by tens. And what I'm going to do is I'm going to graph each of these points on the number line. So 61 would probably fall right in there, and it's pretty obvious by that number line that 60 would round to the nearest, that 61 would round to 60, which is its nearest 10. If I put 37 right there, again, it's a nice quick visual that the nearest 10 it rounds to is 40. And 15 would fall right in the middle. It would fall right between 10 and 20. So it's equidistant from both. So this is kind of a tricky part. You just have to know it's convention that if a number falls in between two possible choices that you're rounding to, you always round up. You're always going to round to that value that is on its right. So 15 is going to round to 20. Now for the next problem, we're going to pause here. All right, so here are some for you to try. I ask you to round them to the nearest 10. I recommend putting them on the number line and seeing which 10 it falls closest to, and that is your answer. Okay, so stop your video, try the here are some for you to try, and then start the video and we'll go to the next page. So you'll notice on the next page it says round to the nearest hundreds. So it only makes sense that I've given you a number line that goes up by hundreds. So if you're going to graph these to see which 100 it falls close to, this is the perfect number line. So 650 would be here, so 623 would maybe fall right around here. And a nice quick visual, the closest 100 it would be is 600. 1088. Okay, here's 1000, here's 1100. Smack in between these two would be 1050, so 1088 would be on the right side of that, maybe about right there. So it's a nice quick visual that rounds closest to 1100. And then 350, okay, that's the one, right? That's kind of tricky. It falls right in between 300 and 400. So like what I said before, you're just going to round up to the closest 100 in this case. So that would be 400. So pause the video. Here are some for you to try. Go ahead and plot those three values and then put your answers on the right hand side. The last one we're going to look at, obviously by that number line, is the nearest thousands. Okay, so we're going to do what we did before. We're going to graph these on this number line. So halfway would be 3,500. So maybe 3,226 would be, maybe right around here. But it's a good visual to see that 3,000 is the closest thousands for that. 4,985, well, that's really close to 5,000. That's pretty obvious that that's much closer to 5,000 than 4,000. And 250, okay, this would be 50 in there. So 250 would fall right here, and the closest one, I know that looks funny, would be 0. Okay? So take a pause, plot those values, write the nearest thousands in the answer, and then restart the video and we'll keep on going. Now if you don't want to make a number line for all these, there's just some rules. They're just plain old rules for rounding. And so you can read these here, and while I'm doing them, I'm just going to go step 1, 2, and 3 while I'm doing these questions. Okay, so step number 1, locate the digit to the right of the given place value. Okay, so I want to round to the nearest 10. So the first thing I do is actually I'm going to underline what I'm trying to round to. There's my tens. And then I'm going to look to the right. Now I'm going to either keep the 7 or I'm going to make it higher. Those are our two choices. So I look to the right. If that digit is 5 or greater, we're going to make that increase by 1. If it's less than 5, then we're just going to keep it. So we're going to keep all those digits that are prior to that tens, and definitely we're going to keep that 7. We're not going to move it up to 8. And then we write a 0, right, to everything that follows now to the right. Wouldn't you agree that 73 is closer to 70 than it is to 80? Yep. Okay, round this number to the nearest hundreds. So I underline the 100. I'm going to keep that 5 or make it a 6. We look to the digit to the right of the 5. Is that bigger than 5? Is 7 5 or higher? Yep. So we keep all the digits prior to the hundreds, and we're going to make that a 6, and then zeros for all the digits that follow. Because 573 is much closer to 600 than it is to 500. Okay, to the nearest thousand. Underline the thousands. We're either going to keep the 4 or make it higher. How do we know? We look to the first digit to the right. If it's 5 or more, we make that 4 into a 5. We add 1. And then you make zeros for everything that follows. All right, round this to the nearest 10,000s. Here's the 10,000s. I need to either keep the 1 or make it higher. How do I know? You look to the first digit to the right. Okay, it's less than 5, so I'm going to keep it. And then make zeros for all of the digits that follow. So whatever number you underline, you keep or make it higher, and then everything else that falls to the right of that, you make zeros. Okay? So take a pause. See how you do. This one is a little bit tricky. I'm just going to give you a hint, right? Well, it's not that tricky. Let's look at these. So make sure you underline the 10, underline the 100 here, underline the 9, and then you either keep or make it higher. Okay? Now the last part, to kind of the rounding estimation part of this section, deals with estimation. So now that we know how to round, we can make some what are called estimations. So let's look at some examples, and then we'll come back and try to understand what estimation means. So it says round each number to the nearest thousands to estimate the sum, or that should be sum or difference. All right, and then we're going to check our estimation by calculating the extra sum or difference. So you may want to take a pause and go get your calculator. Okay, so we're rounding these to the nearest thousands. Okay, so I underline the 1,000. Am I going to keep the 3 or make it higher? Well, obviously the number to the right is definitely lower than 5, so I'm going to keep that 3. Round it to the nearest thousand. So I look at the 0. Do I want to keep it or make it higher? Well, looks like I'm going to make it higher. Now I bet you can just do this without your calculator. 11,000, if I add 3 more, that's going to be 14,000. So that is our estimation or an approximation to that sum. So let's check it, see how close we are. So 3,084 plus 10,987. Look at that. We are not that far off. That's a good estimation. Okay, let's try the difference. Okay, let's round it to the nearest thousands. So look at have the 3, look to the right. Am I going to keep it or make it higher? I'm going to make it higher. And then zeros to all the digits that follow. Underline the thousands, look to the right, keep or make it higher. Looks like I'm going to keep it. And then zeros for everything that follows. So 14,000, take away 4,000. We don't even need a calculator for that. That estimation would be 10,000. Let's check it with our calculator. So 14,000 minus 4,000 is 10. Well, that was our estimation. Let's try the actual. So 13,893 minus 4,019. All right, here's the actual answer. 9,874. Look, we are not that far off. That's a good estimation. So an estimation is an approximation to the actual sum, difference, product, or quotient. So an estimation is an approximate answer. An approximate answer or approximate solution to a sum, difference, product, or quotient. It's an approximate solution found by rounding the original numbers. Or values. So it's just an approximation. All right, let's try our rounding. Now we already know our rules for rounding. Remember we talked about the mental rules for rounding? All right, so now this says round each number to its highest place value. Okay, so the biggest place value for this number is 10. It's in the tens position. So what do I keep the 8 or make it higher? Looks like I'm going to keep the 8, so that would be 80 times. The highest place value here would be our 10,000s position. Do I keep it or make it higher? Looks like I'm going to make it higher, and then zeros for all the numbers that follow. Now we talked about this. We talked about mental multiplication. Remember what we do is we multiply the first non-zero digits. So 8 times 5 is 40. And then we count up the zeros, 1, 2, 3, 4, 5, and add those on. 1, 2, 3, 4, 5. 1, 2, 3, let's count over our 3 periods, so it looks like 4 million. We can check that with our calculator. See how close we are. Yeah, we are not far off at all. Look, that's 3,982,174. Not far off at all. So these are good estimations. They're good approximations to the actual solution to these operations. All right, let's try this one. The highest digit is the 100s. Do I keep it or make it higher? To the right. Yeah, it's a big number, so we're going to make it higher. And zeros for all the numbers that follow. 38, tens position, definitely make it higher. So you remember how we did this mental division? We divided the non-zero numbers. So 8 divided by 4 is 2. Crossed off any zeros, right, that exist in the numerator and denominator, and we have 1 0 left. Okay, here are some for you to try. Pause the video, take your time. You know how to do each of these. Now keep in mind, the 13 and 14 just say round to the nearest hundreds. So we're going to underline this one, we'll underline this one, and then you do the keep or make it higher, right? We'll underline the hundreds positions on these. These, 15 and 16, just say round to the highest place value, okay? So whatever is the first number, that's what you're going to be rounding to, and then you either keep that number or make it higher. So pause the video, see how you do. Okay, the last part of this section talks about perfect squares and square roots. So what I did is I just started this chart. We can go as high as we want, but I just stopped it at 13. And you notice what I'm doing, I'm just taking these counting numbers. I didn't start with 0. You could, but 0 squared is just 0. So I have these nice counting numbers, natural numbers, and then I'm multiplying it by itself. And then I'm going to write this, what's called a perfect square. 1 is a perfect square because it's 1 times 1, or 1 squared. 2 squared is 4. That's called a perfect square because it's 2 squared. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10, that's 100. Now, if you don't have any more memorized, you can just go to your calculator. And you have this nice squared key. So I'm just going to put 11 squared in there. Got 121. We'll put 12 squared. 144. And we'll just stop here. We could keep on going forever, but we'll just stop here. 13 squared is 169. All right, so that is an operation that we're really familiar with. But now what we're going to do is the reverse operation. And it's what's called the square root. So here, with this chart, we were given a whole number. We multiplied by itself to get a perfect square. Now we're going to start in this column and say, okay, what number did we square to get 169? And that is what's called taking the square root. All right, so let's look at this. This is read as the square root of 25. And what it means when you see this symbol, it says, to get to the answer, it says, what number did I multiply by itself to get 25? Well, let's look at our column. It looks like the number that we multiplied by itself to get 25 is 5. So, the square root of 25 equals 5. Let's look at this one, same thing. This is read as the square root of 81. To find a solution, you have to say to yourself, what number did I square to get 81? Well, let's look at this column. Oh, right there. The number I squared to get 81 was 9. So square root of 81 is 9. Now you can do that on your calculator as well. Let me show you where the square root button is on your calculator. Let me show you. So if you look at this calculator, the square root button is in green and it's right above the x squared. So since it's green, I've got to hit this green button first. So if I hit the green button and then this key where it has the square root right above it, do you see the square root pops up? So if I wanted to just find the square root of 4 without that chart, it's 2. And the reason why it's 2, because 2 is the number that you would square to get 4. Alright, if I wanted to take the square root of 36 and I didn't want to look on the chart, you have to hit this green button first and then the key that has the square root right above it. 36, hit enter. It's equal to 6 because 6 squared equals 36. Okay, what number did I square to get 9? 3. So the solution is 3 because 3 squared equals 9. That's not so bad, right? Now, some numbers are not perfect squares. So their square roots aren't whole numbers, or they're not nice fractions. But we can approximate the square root by using our list of perfect squares. Now, some of these questions are going to be on the non-calculator portion of your test. So you have to be able to do these. All right. So this is not a nice perfect square. I'm going to flip back. So these are my nice perfect squares. You'll see that 7 is not among them, right? But if I look, 7 would be stuck right between 4 and 9. Right? 4 is a perfect square and 9 is a perfect square, but 7 is stuck in between them. So that means if 7 is stuck between 4 and 9, then the square root of 7 would be stuck between the square root of 4 and the square root of 9. Right? Okay, so the square root of 4 is 2, and the square root of 9 is 3. So square root of 7 is between 2 and 3. It's between 2 and 3 because the square root is between the square root of 4 and the square root of 9. Okay, let's try it again. Square root of 88, that is not a perfect square. I'm telling you now, it's not on this chart. Okay, but 88, I'm hoping you'll agree, is stuck between it's stuck between 81 and 100, right? Isn't 88 in between 81 and 100? Yeah. All right. Now, the square root of 81 is 9. The square root of 100 is 10. So I know that the square root of 88 has to be stuck between 9 and 10 because the square root of 81 is between the square root of 88. Not between 81. Because the square, let's start this again. Because the square root of 88, there we go, is between the square root of 81 and the square root of 100, right? Wouldn't 88 be stuck between 81 and 100? So because the square root of 81 is 9 and the square root of 100 is 10, and square root of 88 is in between them, it's got to be between 9 and 10. Whew, let's try one more. Ready? Square root of 50. 50 is not a nice perfect square. But I can tell you now, 50 is between 49 and 64. So don't you agree? If we were doing these on the number line, we'd go 40, square root of 49, square root of 50, and square root of 64. Doesn't that make sense? Well, the square root of 49 is 7. Square root of 64 is 8. So then I know the square root of 50 has got to be stuck between square root of 7 and, or stuck between 7 and 8. Doesn't that make sense? If this equals 7 and this equals 8, then this has to be stuck between 7 and 8. All right, now let's check it with our calculator. Okay? Now, let's look at square root of 7. Is it some number between 2 and 3? We might have to change the mode. This is interesting. All right. Now, if this happened to your calculator, we're going to have to change the mode. So, on your calculator, do you see the word mode? If I hit mode, mine is what is called math print. So, if that is happening to you while you're trying to do your homework, change it to classic. So, what I did is I hit mode, and then you saw me use my arrow down key till classic was blinking, and then I hit enter. So now my calculator's in classic mode. So I'm going to quit. Do you see the word quit? It's in green, so I have to hit my green button first. And now let's go ahead and try the square root of 7. There it is. It's stuck between 2 and 3. So I'm going to, instead of this equal sign, you're going to see in the book they use this kind of squiggle, and that just means approximately. And I'm going to round it to 3 decimal places. So I'd underline the 5, look to the right.